All right, 1-4. Absolute value. Remember the absolute value bars? What does that mean if stuff's in absolute value bars? It's a grouping symbol, but what does that mean? The result will come out positive, right? What you can put in is anything, but the result will come out positive. So let's do some substitution. We got W, X, Y, and Z here. Let's substitute in here. Start with the bars and make your absolute bars a little bit taller than your numbers so they don't look like ones or something like that. So we got 6 plus Z, where Z is -6, correct? So let's substitute that in, minus the absolute value of -7, which you could maybe figure that out on your own first. But all I did was substitute in. Cool? And an absolute value bar is a grouping symbol, just like parentheses are a grouping symbol, just like a fraction bar is a grouping symbol. You got to do what's in there first. So in here, we can do a little bit in our head. What's 6 minus 6? 0. Then what's the absolute value of 0? 0. This minus will come down. In here is -7. There's nothing to do in there, but they're asking for the absolute value of -7. So what is the absolute value of -7? 7 shoots out of there. And you're left with 0 minus 7, which is -7. We coup with that first one. Substitute in for number 2 for me. But when you substitute in, realize that you don't want to put a dot and then a minus symbol right next to each other. You use parentheses instead. Cool? Order of operations. Do what's inside the grouping symbols. -4 times -6 is 24. Then the absolute value of it is how much? 24. Absolute value does not mean change the sign. It means it's got to come out positive. It was already positive, so it will stay positive, right? And then in here, what's 2 times 1/2? 1. And what's absolute value of 1? And the minus sign stayed there, and then we get 23. Are we okay with what's going on these? Let's skip down to these. Cool? That was straight sub in, follow order of operations, and etc. Here's the process, my friends. We've got it nice and typed out for you. So when you're stuck in GPS or you're at home and it's like, oh my God, what is going on with these problems? This is the process to solve an absolute value equation. If we go back to these were not equations. They were just expressions. There's nothing to solve. We just simplified them. Cool? Now we need to solve. We need to figure out what kind of numbers make this true. So here's the first step. Make sure the bars are all by themselves on one side of the equal sign. Meaning there's nothing like this. Do you see this next one right here? Aren't these the absolute value bars? But isn't there also a -5 like outside those bars? Our job is to get the bars all by themselves on one side of the equal sign first. Cool? That's what isolate the absolute value bars mean. Cool? So we're good to go here, right? And now there's 2 situations, because let me give you the most basic problem right here. Let's say I just had absolute value of x equals 5. Aren't the bars all by themselves on one side of the equal sign? Can you think of a number that would make this true? What's the value of x that would make that true? X could equal 5, correct? That would make it true. Is there anything else that would make this true? If x was -5, wouldn't we put that in there? And doesn't that still turn out to be a true statement? Because what's the absolute value of -5? So when we have an absolute value equation, there's like 2 situations. When the bars are all by themselves, who cares what's in there? We need to set it up for 2 scenarios. It will either be this number or the opposite of that number. Cool? So are the bars all by themselves? So we'll take what's in the bars, 2x minus 3. And try to save some space. We're going to need a lot of space. So if you got big handwriting, it's time to maybe scrunch it down a little bit. Okay? Save some space. We're going to take what's in the bars and set it equal to what we see. Right? We're rewriting that equation. Then we'll throw the word or here because we've got a whole other situation. We'll take what's in the bars of 2x minus 3 and set it equal to the opposite of what this number was, -17. Just like you told me in here, x could have been 5 or x could have been -5. We're saying what's in here, this red blotch, is going to either be 17 or -17 to make that turn out to be true, right? Who cares what's underneath there? Would you believe that if there was a 17 under there, this would turn out to be true? Or if this was a -17, that would turn out to be true. So that's what we did. We said, oh, it was 2x minus 3. I needed to either be 17 or -17. So let's solve both situations. So let's do it. Add 3 to both sides. Let me do it in blue to keep things consistent. constant. So 2x equals 20, and then x would equal 10, right? That's the one on the left. Solve the one on the right also. And slow down. You know, it's not a speed process, this negative stuff and all that. Negative 17 plus 3 is how much? Negative 14. And then we'll divide by 2, and x will equal negative 7. So far, so good. We have done this. We have isolated the bars. They were already all by themselves on one side of the equal sign. Then we wrote the two different equations representing the two situations, and we have solved each one. But absolute value doesn't always work perfectly. Sometimes that we can get some real algebra solutions that just don't make this equation turn out to be true, so we need to check to see if these answers work for the situation. That's checking for extraneous roots, meaning it was an answer in your algebra process, but that answer doesn't make the original equation true. So we've got to check for extraneous roots. So that's where we put the nice little squiggle, and we check each situation. And OMG, it's a lot of work. Like, don't get me wrong, this is a lot of work, but we have two situations to do it in. First, let's put 10 in for x. So I can do a little bit of cheating, do a little bit at one time. If I put 10 in for x, can we already take 2 times 10 right away and get how much? 20 minus 3 equals 17. And you see how I kept it in the bars and all that good stuff, right? And now I can do, this is so simple, we can do it mentally. What's 20 minus 3? And the absolute value of 17 is? So 17 equals 17. Did a check. Then we go up here to this answer, ba-boom, and say that one worked. That one was great. If x was 10, this turned out true because 17 equals 17. Feel good? Now let's check negative 7. So I'll go over here, and I'll say, I'm putting negative 7 in for 2. Do that in my head. What's negative 7 times 2? Negative 14. And then minus 3 equals 17. And it's not about a mental check, right? It's not a mental check. It's an on-paper check. I need you to show me this stuff. Because some of these I know we can check mentally. You put it in, you do it in your head, and you're like, yep, it worked. It worked. It worked. I need to see it. Does that make sense? So in here, then, I want you to simplify it down to negative 17 inside the bars. And is the absolute value of negative 17 really 17 equals 17? Didn't that one check also? So, bada boom. They both worked. Sometimes they'll both work, sometimes they won't. In this case, they both worked. That was step 4. Check each equation, eliminating any extraneous roots. We didn't have any extraneous roots. And this is what's new to most of you. Write the answer now as a solution set. How many solutions did we get for this situation? 2 of them. X could have been 10, and x could have been negative 7. So that's what this fancy schmancy set bracket is all about right here. That is a difficult thing for us to make, but please do your best to make me a set bracket. If you can't, just don't make a parenthesis. At least give me something squiggly. You know, up here is what I just did. Try your best, and you will get better and better and better at making that set bracket, because that's what we're going to do the rest of the year. The 2 solutions were 10 and negative 7, and then close that bracket off in sets. We just put it in there. It doesn't matter what order they're in, if it's negative 7 before 10 or 10 before 7, but those are all the solutions. This right here says the set of solutions is 10 and negative 7. That's everything that made this problem work. Cool? Let's do it again. Let's go through these 5 steps. What's the first thing we need to do? Isolate the bars. So what is the move that we need to do to isolate the bars? Add 5 to both sides. So the bars have not disappeared yet. A lot of people just start writing it without those bars. No, no, no. And now I want to add some common sense to this. Have we isolated the bars now? Yes, we have. It's a common sense check. Let's pretend that it was this. Instead of a positive 5, it was a negative 5. What's this representing right here? Absolute value? Who cares what's in there? What do you know about absolute value? What kind of numbers will shoot out of that every single time? Positive numbers. And if this says negative 5, Will there be any numbers that will even work? Will the absolute value of something ever come out to be -5? So I kind of have an extra thing to check for besides these 5 things. Once you've isolated the bars, common sense. Will we get some solutions to this one if this is coming out to be +5? Yes or no? This is 5 now. It's not a negative. I changed it back. This is 5. Will we get some solutions? Yes. So let's follow the process now. Let's rewrite it with 2 equations. Take what's in the bars. Now the bars disappear. Because we've isolated the bars, we're going to set it up. The bars disappear. T minus 4 would equal 5. Or what else? T minus 4 equals -5. The stuff that was in the bars never changed, right? It's always T minus 4. It's the other stuff. Remember, if I black that out right there and just put an X, right? And I said, what could X equal to make this true? X could either be 5 or X could be -5, correct? But it's not an X. It's a T minus 4. So we have to say, well, T minus 4 could equal 5 or T minus 4 could equal -5. Solve both situations. Please pause the video and get that done. So we got T is 9 and T equals -1. We don't know if they're going to work. Let's put a little squiggle and do a little check. So I'll have absolute value of 9 minus 4. And then keep it the same. -5 equals 0. Do you see how I didn't use any of these other equations that we have like right here? These are not the equations we're checking. We're checking the original guy right here. So we're just going straight back into this. Cool? You with me? 9 minus 4 is 5. What's the absolute value of 5? So we have 5 minus 5 equals 0, and that means 0 equals 0. Isn't that a true statement right there? So that bad boy checked. Now do that for -1 also. And I will also mention on your homework, sometimes there just isn't room to do all of this stuff, to solve these, to check them and all that stuff. If you feel the need, you got to go to a separate sheet of paper, do it. And then when I'm walking around checking stuff, just be like, here's those problems. Very nice. They both work. So what's still left to do for this problem? We've got our solutions. There was no extraneous solutions. What do we need to do? Solution set. That's what it's called. We need to learn to call it the right thing. Because, let me tell you, you will find out real fast. You can ask some of your friends who are in college algebra right now. They're struggling with the homework because they don't know how to read stuff that's in set notation. They don't know how to read it. So the more we can say it correctly, the better you will be successful. Next one. This one is extremely ugly. Are the bars all by themselves on one side of the equal sign? That's the first question for you on this one. Yes, they are. But you also notice that there's something just kind of really different about it also, even though the bars are all by themselves. There's a variable on that not have anything to do with the bars. This is where things get nasty, right? This is where things get nasty. So here's our process again. Isolate the bars, done. 2 separate equations. Always the same process. Take what's in the bars first, m plus 3. And set it equal to what you got. And I know it's like backwards the way it's written, but I always do it the same way. In the bars equal to what we had. We cool with that so far? Or, I will show you the right way to do this the first time, and then we'll kind of skip some steps. Take what's in the bars again, m plus 3. And set it equal to, here's how to explain it. You take the opposite of what's out there, so minus parentheses 12 minus 2m. You see how that was still what this was right here, but I want the opposite of it. Rock and roll? Now, what we can do is solve the blue one for sure. Let's solve the blue one. We got m's on both sides, so let's get this minus 2m over here by adding 2m. You with me? So that'd be 3m plus 3 equals 12. and then keep going. Solve that for m. Are you good with m equals 3 in my blue situation? Cool. Let's go to the red situation. First move, I highly recommend, I know last time I tried to show you a shortcut, I highly recommend that we just distribute that negative through. Okay, this is a -1 outside parentheses. It needs to get distributed through. So m plus 3 comes down, and that would equal -12 plus 2m. And let's stop and see if we can realize how to do this a quicker way for the next times. How do these numbers relate to what was originally there if we distribute a -1 through? They're the opposite. Isn't this a -12 and that's a plus 2m each time, right? So hopefully the next time we do these, we can kind of skip this step of put the -1 outside parentheses and just realize all you need is the opposite of this and the opposite of that. Cool? Now solve for m. Before we check, before we didn't get any extraneous roots, do you think we might get some extraneous roots on this one? There's numbers that just like won't check. Did this one seem funny looking to you at the beginning? It was funny because there was a variable out here that was not involved with the bars at all. Highly likely that some of these numbers aren't going to make it work. Okay? So let's try. Let's try. Let's put a little squiggly, and let's put 3 in for m into the original equation. What you see, just put a 3 there. 12 minus 2 times 3, which I'll just go ahead and put a 6 there, equals absolute value of 3 plus 3. I did a little bit in my head. If you struggle with that, don't try to skip steps. Just substitute in. You know, it's your ability. You know it better than I do. Cool? 12 minus 6 is 6. 3 plus 3 is 6. Absolute value of it is 6. That worked, right? 6 equals 6. So 3 was a solution to this situation. Let's try 15 now. Put 15 in. So I'll have 12 minus 2 times 15, which is 30, equals absolute value of 15 plus 3. What is 12 minus 30? -18 equals absolute value of 15 plus 3 is 18. Does -18 equal 18? No. So then over here we put an X right there. That did not work. 15 worked when we set it up like this. We broke it out and said 15 would kind of work algebraically in this situation, but it does not work back in the original equation. That is an extraneous root. So we have done this. We've done all 4 steps. It is now time to write the answer as a solution set. Which numbers worked? 3. And that's the only solution. 15 was an extraneous solution. It worked in this algebra, but it did not make this original equation true. Cool? Next one, number 10. What's step number 1? Isolate the bars. Get that done for me. So please pause the video, get that done. Are we down with that by subtracting 16 from both sides? Yes? I have a step 1.5. Right? Something in between. It says after you've isolated the bars, common sense check. This is absolute value. And tell me about that number right there. That's negative. Can the absolute value of something ever turn out negative? So we could solve this all day and we'd get 2 solutions when we do our solving. Then we'd have to substitute them back in, and neither one of them would work. Because how many solutions are there? There's no real solutions. Empty set is what we do. Common sense saves you time. Says, hey, we could set it up 2 ways, solve both, get 2 answers, and then substitute back in, and you get extraneous root and extraneous root. Because this is a negative number, it doesn't matter what's under there in green. There is absolutely no way that the absolute value of something will come out negative. It can't happen, right? People are like, well, what if you put -14 in there? All right, I'll put negative 14 in there. What's the absolute value of negative 14? It's a positive 14. It cannot come out negative. So, boom. And then that is set notation. Like the solution set, it's a circle with a slash through it. Don't make this. That's theta. Hopefully you learned about that. It's circle with a slash through it. For those of you who make your zeros that way, stop making your zeros that way. That doesn't mean zero. That means empty set. Cool? If you wanted it with set brackets, there's what it looks like. What's in the set? Nothing. It's empty, right? It's the empty set. So, boom. Next one. Isolate the bars. Are the bars all by themselves? Yep. You got a funny feeling about this one now? It feels kind of funny because there's a variable out there. So let's do this. Let's take what's in the bars of 8 plus 5a and set it equal to what we see over there. Because the bars are all by itself, we're ready to rock. There's our first one. So far, so good. The second one is we still take what's in the bars, 8 plus 5a. You remember how we distributed that negative 1 through on all there? It's opposite of this number, which is negative 14, and opposite of minus a, which is really a plus a. Are we cool with that before we move on of where those came from? It's the opposite of this, which changes all the signs. Solve them both. Please pause the video and get both solved. So we should have got a equals 1 and a equals a negative 11 halves. Let's check for extraneous roots. That's step 4. So squiggle shows me you're doing some other work. Let's try 1. That's a nice number to deal with. Skip a little bit of step. You got 14 minus 1. Doesn't that just turn out to be 13? And then you got absolute value of 8 plus 5, which is 13 equals 13. Is that one okay with us? And then we go about and put a check next to it. Check. That answer worked. It checked. Now, putting a negative 11 halves in there. 14 minus a negative 11 halves plus 11 halves equals 8 plus 5 times a negative 11 halves. I did straight substitution there because that's a mess. You know, just subbing it in. Awesome. I don't want to move too fast. Are we okay? I got to add these up. I want to get a common denominator. Isn't that 14 over 1? I need it to be over 2. So what does 14 over 1 turn into if you put it over 2? You double each thing, right? This needs to get multiplied by 2, and so does that. And then I just lightly scratch that out. That's really 28 halves. Now I can add it to 11 halves. It will still have halves for a denominator, and it's 28 plus 11, 39. Cool? Over here, I still have absolute value. There's an 8. I need to multiply these two numbers together according to the order of operations. Isn't that going to be numerator times numerator, a negative 55 over 2, right? Numerator times numerator, denominator times denominator, and close the bars. Now, let's change this to 16 halves, so I could subtract those from each other. So 39 halves comes down. It will still be over 2 right here. And 16 minus 55 is how much? You can use a calculator. 16 minus 55 is how much? Negative 39. So, oh, no. Did it work? Yeah, it did. Yeah, it did. Because what still did I forget that is around it? Absolute value bars. And last I checked, 39 halves equals 39 halves. Check. It was suspicious from the start. But by way of checking, it still was a good solution. Write the answer as a solution set. So I will show you another mistake. Here's my solution set. This is wrong. That's what I put for my answer. Why is that wrong? I don't care about these numbers. I care about these numbers, right? The solution set is 1, negative 11 halves. When your brain starts to get tired, that's when mistakes like that happen. It's a lot of work. It's a lot of blah, blah, blah. Follow the 5 steps. Let common sense take over between steps 1 and 2, though, to help you out. Okay? Next one, 12. You and pal, discuss it. I will have you pause the video and figure that out for yourself. Because that was negative, that is an empty setter. Next one. First thing, does it seem fishy? Got variables outside the bars. So step 1, what's the first thing we do? Isolate the bars, right? They are not isolated. What's our first move? This needs to go over there, right? So let's do it. Let's do it. Let's subtract 5f. And what comes down? Negative absolute value of 3f plus 4 comes down, and you have negative 5f plus 20. Is that cool? This minus is still outside the bars. Rock and roll? And that's a times negative 1, right? There's really a negative 1 right there. It's just like that's a parenthesis. I need to get rid of this times negative 1 by dividing both sides by negative 1. So what will come down is the bars still. And if you divide by negative 1, that changes all the signs. 5f minus 20. So far, so good. Common sense check doesn't work when there's variables over here. People are like, hey, can't you do your common sense check now that we have the bars all by themselves? That 20 is negative, so there's no real solutions. That common sense flies out the window if there's a variable over here. It only works if it was just a constant number. Okay? So if there's variables, you got to go through the whole process. So let's do it. Set me up 2 equations with your partner. You take what's in the bars, 3f plus 4, and set it equal to what you see for the first one. Or you take what's in the bars and set it up equal to the opposite of what you see. So what would it equal over here? Negative 5f plus 20. Now solve each situation. Hopefully you get f equals 12 and f equals 2. Are we okay with those? Now it's time to check to see if there's extraneous roots. You know, space is a valuable thing, and let's pretend that I had problems right here. Well, can I make a little spot right here to do some work, right, to check myself? So that's what I want that squiggle for, to just kind of separate your work from the other stuff. So let's check 12. I got 5 times 12, which you can punch that in if you want to, or if you know it. 5 times 12 is how much? 60, minus the absolute value, 3 times 12, plus 4 equals 20. We cool? 60 minus 36 plus 4 is 40. Absolute value of that is 40. And the minus was on the outside, right? The minus was on the outside over there. And then 60 minus 40 is 20. So 20 equals 20. Check. Now let's check 2. So squiggle, squiggle, squiggle. Putting 2 in. Did 2 work? No. So we go to 2 and we put an X right there. It did not check. Then we write our answer as a solution set. And it's hard to find a spot for that, but find a spot, the number that worked was 12. And if it's in a big mess, give me a nice, neat circle around it so I can try to find it. Space is valuable. Cool.